For this problem, notice that we need to find out the area unbounded by the curve mod x plus mod y less than equal to k. And then if k is the area. Now we have to find the f10. That's the problem. So let's go ahead and solve it. Now, here to solve this one, first we consider, right, the x-axis and y-axis. Why? Because see that here we have mod x and mod y functions. So therefore, in different quadrant, the curve mod x plus mod y equal to k or less than equal to k will behave differently. Or that means it will change its definitions. So let's go ahead. So here when we draw the x-axis and y-axis, we are divided into four quadrant, that is 1, 2, 3, 4. In the first quadrant, we know that x and y both are greater than 0. In the second quadrant, we have x definitely less than 0, and for the case we have y is obviously greater than 0. For the third quadrant, we have that x is definitely less than 0 and y is definitely less than 0. Both is less than 0. Here x is greater than 0 and y definitely be less than 0. So these are the properties of first, second and third quadrant. Now notice that in the first quadrant, right? So let's go ahead in the quadrant 1. So here we can consider that quadrant 1. In quadrant 1, what will be the equation? We know that as x and y both are greater than 0, mod x can be written as x and mod y is also equal to y. So therefore we can say that in first quadrant we need to find out the region bounded by x greater than 0, y greater than 0 and x plus y less than equal to k. Similarly, in the second quadrant, we have that obviously x is negative because x is less than 0. So minus x plus y because y is greater than 0 less than equal to k. In the third quadrant, let's write down in third quadrant x and y both less than 0. So therefore minus x minus y is less than equal to k. And that's it. And the last quadrant is left, that is in fourth quadrant. In fourth quadrant, x is greater than 0. So therefore it will be plus x minus y and that's less than equal to k. So these are the fourth quadrant we have. So renamed it as quadrant number 1. This you can for your basic understanding. So this is quadrant 2. This is we can rename it as quadrant number 3. And the last one is quadrant number 4. Now see that if we draw all those respective lines, right, and then join together, we can easily observe that we get a area of a square. So I named it. So here we say that intersection point in A, B, C and D and the origin is O. So therefore we can say that thus fx, the area bounded by the given curve, must be equal to area of the square ABCD. This is definitely a square. Now as it is a square, so therefore by the properties of the square, all the triangle you are able to see, they are equivalent or based on that congruence, or the area will be equal. So therefore we can say that one triangle area will be 1 by 2. Let's go ahead, we'll find out OB multiplied by OA. And there are four similar kind of triangle, right? Not similar in the sense that geometrically area is same, right? So therefore it will be 2 times of OB and OA. You see that what is OB and OA? That's the x and y intercept of the straight line AB. What is the equation of the line AB? By observation and whatever we discussed earlier, the equation of AB is equal to x plus y is equal to k. If I write down in x and y intercept form or axis intercept form, it will be x by k, y by k, and that's equal to 1. So that's definitely imply that OB is equal to k x intercept and y intercept, that is OA, which is obviously equal to k. So therefore fx can be easily written as 2 times of k multiplied by k, that's equal to 2 times of k square. That's it. So therefore we can calculate what is my f10. That's very simple, that is 10 square, that is 100 here, multiplied by 2 obviously means that, okay, so it will be 200, and therefore that's imply that f10 divided by f100 is equal to 2. Is the option is available? Yes. So option C. So option C is the correct option. That's it. Let's go ahead for the third problem.